ask you a question. Can you actually make a stable structure using just strings and sticks? Well, actually you can. That is why in today's video, I'm going to explain about a tensegrity structure. As you can see here, this is a simple 3D model of a tensegrity structure made out of popsicle sticks and strings. A tensegrity structure is a structure made out of two types of components. Components that are in compression and components that are in tension. So based on this structure here, we can see that the components that are in tension, which are being pulled, are these strings. These 4 strings that stable and support the structure. And the components that are in compression, which are being pushed, are the top and the bottom, made out of popsicle sticks. So, in order to understand how a tensegrity structure is able to be stabilized just by strings, let's look at a 2D model of a tensegrity structure. Okay, here we have a 2D model of a tensegrity structure. As you can see, it is made out of cardboard and elastic bands. To explain this tensegrity structure, let's look at some little scenarios. So, if I tilt this top part of the structure to one side, you can see that this string here is now in tension and is being pulled. That means there will be at least one string being stretched. So this tension that this string is experiencing now will make the structure go back to its equilibrium position. Same can be said if I tilt the other side. You can see this string is now experiencing tension. So if I release it, it returns to its equilibrium position. That means the tension in the string is what keeps a tensegrity structure balanced. And this middle string, along with these two components, provide the support to the structure. Okay, so now let's try to apply what we've learned or discovered in the 2D model to the 3D one. So in the 2D model, we have seen that if we compress one side of the structure, the string at the opposite side of the structure will be experiencing tension. And this tension will be the one that will bring back the structure to its equilibrium position. So let's try it on this one. Okay. As you can see, as I am compressing this side, these two strings are experiencing tension. Okay. The more I go down, the more these strings are being pulled. Okay, so now, what happens if I actually release this side? Will it actually go back to its equilibrium position? Let's see. Okay, 3, 2, 1. Ta-da! So, the tension experienced by these two strings just now have restored the structure back to its equilibrium position. So now, let's see how much this structure can actually hold. Can hold a mouse. Okay, so what actually happens if one of the strings can't actually support the tension? So let's see. Which side? Whoops. So as you can see, the compression at this side is actually too much for the string to handle, so the structure has collapsed. Okay, just now you've seen the few examples where I place some objects on top of the structure, and the same rule applies. If I press down one side, the other strings will experience tension, and the tension will bring the structure back to its equilibrium position. The structure is actually quite strong, as you can see. You can push it this side, you can tilt it, but it's actually pretty strong from the top. This is because of these three structures in the middle, these three components. So these two sticks, and this little thread in the middle. So these two sticks are each connected to the top and the bottom of the structure, and these two components are actually experiencing compression, whereas this string in the middle is actually experiencing tension. So these sticks actually provide a compression resistance to this tension in the wire, in this string. Hence, it provides a strong support to this structure connecting both the top and the bottom. Whereas the strings at the side are actually used to balance the structure. As it is being balanced, as we turn, same can be said here and same can be said here. You'll be surprised to actually find out that your body experiences tensegrity. Your tendons in your muscles are actually the strings in tension, and your bones are actually the components in compression. Now for a little demonstration. If you take up your wrist and you bend it backwards, you can see that there's this line forming under your skin. It is pretty visible. Now this is a tendon that connects your hand to your arm. This tendon here is actually pretty strong, and you can see it is now in tension. You can feel this tendon, and you can see that it's actually pretty hard. Now, if you leave your finger there and you slowly turn back your wrist, you realize that this tendon is no longer visible, and it is not as strong as previously. This means our body is structured in a way that allows us to move, to bend our body, our parts in many directions, that allows us to be flexible without having us to have body parts that are in specific positions. So this means we can move, we can stretch, we can bend, and we can all return to our original position or equilibrium position based on the tensegrity in the bones and the tendons. Okay, that's all for this video on tensegrity, and I hope that it is educational for you all and that you have managed to learn something from this video. That's all. Thank you everyone. Bye.